Here is the chart that we used in the previous section, but I wanted to put it here in Unit 7 video as well. So if you need to write it down, you can. You really need to know these for the exam. So go back and study these. Go back and watch the Unit 6 video. Right before problem number 4 in it, we filled out the chart, and I have some work down below which I won't linger on here. But it is explained where things came from. But again, I will show this to you as we get ready to verify our trigonometric identities. And the first one says verify the following trigonometric identities, and we've got cosecant of theta times cosine of theta equals cotangent of theta. Remember, you can only work with one side. You want to pick the more complicated side, and oftentimes it is going to be the left side, and it is on this particular problem. Cosecant, we can rewrite cosecant as 1 over sine of theta, and we're multiplying that by cosine of theta, and some of you need to see that it's cosine of theta over 1. Well, when we multiply these together, we multiply the tops of the fraction together and we get cosine of theta. We multiply the bottoms of the fraction together and we get sine of theta. Well, what does cosine of theta over sine theta equal? Again, you can look back at your chart, but what you see is that it equals cotangent of theta, and over here on the other side, we equal cotangent of theta. Problem number 2. Maybe a little bit more complicated here, but as we take a closer look, the first thing that I notice is that there's a cotangent. I'm looking on the left side. Let me read the problem. Cosecant squared theta times cotangent of theta minus cotangent cubed of theta equals cosine over sine. Well, what I notice again is that there's a cotangent in both those terms on the left side. So let's factor out a cotangent. Cotangent of theta. When we factor out a cotangent of theta, we're left with cosecant squared theta minus cotangent squared theta. And whenever I see an expression that's squared in it, that makes me want to go back to the chart and see, do we have any Pythagorean identity that might deal with cosecant squared minus cotangent squared? So you can look up on your paper. I need to scroll back here. But we've got, right in the very middle of these 9, 1 equals cosecant squared minus cotangent squared. So we're going to flip back to the problem, and we're going to fill in, oh, sorry. We're going to fill in what cosecant squared theta minus cotangent squared theta equals. Well, this is cotangent of theta. And again, looking up at the chart, what we just saw is that cosecant squared theta minus cotangent squared theta equals 1. Well, cotangent times 1 is cotangent. We're trying to turn the left side into the other side, so we need to finish by defining what cotangent equals. And cotangent equals cosine theta over sine of theta. And when we look on the right side of our equation, we see cosine of theta over sine of theta. Problem number 3. My first thought on this one is, do we want to FOIL this? But again, I think I see 1 minus sine squared. Do we have a Pythagorean identity that's 1 minus sine squared? As we flip back here, because you're going to have to flip your paper as well, 1 minus sine squared is in green to the far left. That equals cosine squared. So we can fill that in. Cosine squared. Well, I wonder, do we have a 1 plus tangent squared theta as well? If we flip back to our chart, 1 plus tangent squared is written in black to the far right. It's written as tangent squared plus 1, but what we see is it equals secant squared. So going back to the problem, this is going to be times secant squared theta. And we're trying to get this equation to equal 1 on the other side. Well, I'm going to leave cosine alone because we've done a lot of work with cosine. And I'm going to convert secant squared into its reciprocal function, which is 1 over cosine squared. And what happens is, when we multiply these together, I'm going to do an extra step here, just in case you've forgotten how it works, but we multiply the top of the fraction, and we multiply the bottom of the fraction. Cosine squared divided by cosine squared equals 1, and on the other side of our equation, we get 1. Problem number 4. Let's use what I was thinking that we might have to do on the last problem, and that's the fact that sine of theta plus cosine theta quantity squared means sine of theta plus cosine of theta times sine of theta plus cosine of theta. And what I was thinking originally on the previous problem is that we wanted to multiply those two. But in this particular problem, we don't have any squared, but let's double distribute or FOIL, however you want to refer to it. And sine theta times sine theta is sine squared theta. Sine theta times cosine theta is sine theta cosine theta. Cosine theta times sine theta is sine theta times cosine of theta. And cosine theta times cosine theta is cosine squared theta. We can simplify this a little bit. The first thing that I notice is that these terms are like terms. And remember, there's a 1 in front of that, and there's a 1 in front of this. So this is sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. Something else that I notice, and I'll write it, you don't necessarily have to write this step, but if you're a visual learner, you probably want to. Let's put the squared terms together. And I'm not going to flip back to the chart this time, but hopefully by now it's coming back to you. What does sine squared theta plus cosine squared of theta equal? Well, it equals 1. And then we still have the 2 sine theta cosine of theta. But as we look back at the top of our equation, look what's on the other side. It's 1 plus 2 sine theta cosine theta.